In this video, we will see two ways to set up custom topologies in Mininet network emulations. The first will be by creating a custom topology file that can be used with the mn command. The second example will be with a Mininet Python script run from the system shell to create the same topology. If you are new to Mininet, I suggest first watching my Introduction to Mininet video on my YouTube channel. I also recommend going to mininet.org for full details. Let's jump right in. So here's the topology I want to create in this video. I've got 4 switches connected in a full mesh. All of this runs in Mininet, and then I will use Floodlight as my SDN controller here, C0, on a second VM. The first time I tried a loop topology like this, my laptop crashed because I didn't use a topology-aware SDN controller. So this is a good lesson to keep in mind. Just because we have an SDN-enabled network doesn't suddenly mean we don't have the same old concerns about loops and broadcast storms. As an example, Floodlight's topology and forwarding modules together detect and prevent packets from traveling in a loop, as do other controllers. Custom topologies with the mn command. So this first example is really easy. You'll be editing a Python file, but you really don't need to know Python to do this. So we do this in /home/mininet/mininet/custom. From there, take a look at the README, and you'll see how we're going to run this Mininet with the mn command. See here sudo mn --custom custom_example.py. This custom_example.py will become the name of your topology file. --topo my topo. And in this directory we see there's a straightforward example topo-2switch-2host.py. Let's open that and take a look. We see here what this topology will look like. It'll have a host, and then 2 switches in a row, and then a second host. So we first create 2 hosts, left host and right host. Then we add our switches, left switch and right switch. These variable names, left host, left switch, right switch, these can be whatever you want. However, the strings here, H1, H2, S1, and S2, these should follow the Mininet style, or you might run into some problems. So for hosts, we use H, then a unique integer, and for switches, S, and then a unique integer. After all our nodes are defined, we define the links we want between them. In this example, we link the left host to the left switch to the right switch, and finally the right switch to the right host. And that's really it. This dictionary here you'll probably just want to leave like it is, unless you add more topologies in your file. We use the string myTopo when we run our mn command. So now let's look at my topology for a full mesh. Here it is. I named it mesh.py. And let's look in there. All I did is copy the example file and update it for my needs. In my case, I add 4 switches, again sticking with the Mininet style of naming, and I add 2 hosts. For my links, instead of enumerating out every one, I used a nested for loop to get all of them. This isn't necessary at all, it's just the way that I did it. I've exited out of here, and to run this, all I have to do is sudo mn --custom mesh.py --topo my topo, like the example before from the README file, and I'm using a remote controller, so I'm going to say --controller equals remote, IP equals 10.0.0.11. This is a Floodlight controller I already have running in the background on another VM. And we'll see Mininet starts OK. It brings up all my hosts, switches, and links, and leaves me at the Mininet prompt. If I do the dump command, all of my nodes are here as expected. So I have my 2 hosts and 4 OVS switches and my remote controller. If I run the net command, I can see the links have also been built as I expected into a full mesh. And I'll do ping all, and we see it looks like I do have connectivity. I'll exit out of here, and I will do a sudo mn-c just for a good measure to clean everything up. And we will look at another way to make this same topology. Mininet from a custom Python script. Now we're going to look at the examples directory. This is at /home/mininet/mininet/examples. There are a lot of great examples here, and there's a summary of them all in this README file. These go deeper into the Mininet Python API than the custom topology example I just did, so you get some better control over what you can do. For my example, I'm going to base it off of emptynet.py, so let's take a look at that. Here we manually call the controller, and in emptynet we're just calling the default controller called controller, which is a Python class. Then we add some hosts, and here I actually edited it to change the IPs as something different. So I have 20.0.0.1 and 20.0.0.2 instead of the defaults 10.0.0.1 and 10.0.0.2. Here are switches added, and finally we create links between the two hosts and this single switch. Net.start will launch Mininet. CLI net will get us into the Mininet prompt we're used to when running the mn command. Finally, there is net.stop, which runs when we exit the CLI to stop the topology. So I'll open up my topology. I named it the same as before, mesh.py. In here we'll see it's similar to emptynet.py, but I wanted to call out a remote controller in my case to point it to Floodlight I have running on another VM at 10.0.0.11. So instead of using the controller class like in the last example of emptynet.py, I'm using the remote controller class, and I specify my IP and my port. Here I add my hosts, and I'm back to the default IPs. So technically I actually don't even need to call out these IPs like this, so I can just remove this, but I just wanted to show how that looks. This will give me the same result of 10.0.0.1 and 10.0.0.2. Now I add my 4 switches, S1 through S4, and finally I build the full mesh of links. So here is that nested for loop again, like I did in the custom file example. Again, there's the net start to start up Mininet, CLI, and net stop to when we exit out. Now I'll exit out and run this. And this time I don't use the mn command. I just run the Python script. So I'll do sudo python mesh.py. And it looks like it started okay. My hosts are added, my switch are added. And let me do a dump here. And you see the same nodes like we saw before. So I have my 2 hosts, H1 and H2. I have 4 open vSwitch switches, and I'm pointing to my remote controller at 10.0.0.11. I can do net, and I can see my links are a full mesh as I expected, and I'll do ping all just to verify I have connectivity like before, and 0% dropped, so it looks like that's good too. That wraps up this video on custom topologies. As usual, I can be found at www.linkedin.com/in/davidmahler, and thanks to those who contacted me already from my other videos. In the comments I included a link to the Mininet team's GitHub page where there was a post describing the Mininet Python API in much more detail.